Hello everyone, I am Dr. Billy Kulshrestha and you are watching Erudite Chemistry. And today we are going to continue with the same topic, that is calculation of oxidation state or oxidation number of an element in a molecule. In last video we have already learned how to calculate oxidation state using a simple concept, that is we just added the oxidation states of the various atoms in the molecule and then we made it equal to 0. Just because it is a molecule, it was 0. If we are calculating the oxidation state of the ion, it was kept equals to the charge which is present on the ion. Okay? But when we calculated the oxidation state of carbon in C3O2, remember that? So when we calculated oxidation state of carbon in C3O2, we observed that using that formula where we are not considering any structure of the molecule, the oxidation was found to be fractional. Let's do it again and recall the things. So this is because there are 3 carbon atoms, I am taking 3, and because the oxidation state of carbon here I am taking as X, so I am taking it as 3X. Oxidation state of oxygen in most of the cases is oxide -2, and how many oxygens are there? 2. So I will multiply it with the 2. Total charge on this compound was 0. So this is 3x minus 4. 3x minus 4 equals 0. And this way we are getting that x equals 4 by 3. So this was the oxidation state of carbon in the C3O2. But here we were stuck and we came to know that there is something wrong in this particular oxidation state. Means we are doing something wrong while calculating them. So whenever you are getting the fractional oxidation state, you have to go through the structure formula of that compound so that you can assess what type of attachments are there to decide what is the oxidation state of that element in that compound. So all the time we cannot apply this simple concept for calculation of oxidation state. We have to go through the structure of these compounds. So let's see what is the structure of this C3O2 and actually what is happening and why we are getting this fractional value of 4 by 3. So let's do it. So here I am having structure of C3O2. So this is 1, 2 and 3. 3 carbon atoms in this C3O2 is attached this way. Oxygen and oxygens are attached this way. So this is the structure of C3O2. Okay. So if I talk about the carbon attachment with other carbon or anything else. So look at this carbon. I am starting from carbon number 1, carbon number 2 and carbon number 3. As you can see here, the attachments are different. If I am taking carbon 2 first, what kind of attachment it is showing? It is showing that both the side is connected with the carbon. And already I have told you that whenever any atom is connected with same kind of atom, it is like their family members. So they are not pulling or pushing the electron towards that atom. So what is happening here? This carbon is at actually 0 oxidation state. So basically we have to apply the concept of electronegativity while we are dealing with these structures. So because there is no pulling and no pushing, it is a simple attachment between the two carbon and carbon. So there is no charge created on this carbon. So it is at the 0 oxidation state in this compound, this C carbon, this carbon number 2. Fine. Now look at this carbon. This carbon is attached with the 2 bond with oxygen. Now in this case, whenever you see the bond, always remember that one bond is pulling 1 electron of carbon and second bond is pulling second electron of carbon. And just because it is oxygen, it will definitely be pulling the electron from the carbon side. So what is happening here? One bond minus 1, another bond minus 1. So 1 plus 1, 2. So 2 electrons are being pulled towards the oxygen. That means there is -2 charge on this oxygen and definitely it might be creating +2 charge on this carbon because it is the electrons are being pulled from this side. So if it is gaining, it might be losing. So there is +2 charge on this carbon. Okay, same way we can consider this thing also. So here also there is one oxygen connected and with the 2 bonds, because one bond is pulling 1 electron, here also it is pulling 1 electron. So 2 electrons are being pulled here. So -2 charge. Okay, so what will happen on the carbon? Carbon will have plus 2 charge on it. So what is the oxidation state of carbon? Because there are 3 carbon here, carbon number 1, 2 and 3, and we are taking the average of this oxidation state, and total plus 2 and plus 2, total plus 4 oxidation state is there, and we are dividing this with the 3 carbon atom because we are taking the average here. So this is 4 by 3 we are getting in this case because we were taking average here, but actually what is happening, how this is divided, actually it is not divided. These two are at the plus 2 oxidation state and this is at 0. That is why the charge on these 2 carbon atom is plus 2. Yeah, oxidation state of these 2 carbon is plus 2 and this middle carbon is at oxidation state 0. So basically we have already discussed this thing very clearly that oxidation state is describing the condition of that carbon, whether it is giving its electron to someone or it is gaining the electron from someone. That the condition is the oxidation state. So this is the condition of this middle carbon and rest of the carbon are at the plus 2 oxidation state. I hope it is clear. Now let us see another example of this kind of where we will be getting the oxidation state in fractions. So let's see. So let's start with Br3O8. Before going to structure, let's find out its oxidation state first. So this compound is Br3O8. Br3O8, the name of this compound is tribromo octa oxide. Octa oxide. Oxide means minus 2 oxidation state. So let's see to it. If I am using X for it because I am not knowing, so this is 3X plus 8 oxygens are there and oxidation state of oxygen is minus 2. Total charge 0. So this becomes 3X plus 16 equals 0. So this becomes 3X equals 16 and X equals 16 by 3. So again we are getting this in fraction. So there is again we are in trouble. So we have to go through the structure so that we can understand actually what is going on in this compound. Okay, शुरू करें. So let's see what is the structure of this Br3O8. So actually what is happening here is Br. Okay. Total 8 oxygens are there. So we will be dividing it in such a way so that these 2 bromine are getting 3 oxygen. That is 1, 2 and 3. And this is also having 3 oxygen. And rest of the 2 oxygen we are adding to this. So 1, 2, 3. 4, 5, 6, 7 and 8. So this way it is connected. We all know that the atom which is having plus oxidation state is always at the center and the atom having negative oxidation state are at the surrounding side. So here oxygen is more electronegative than the bromine, so I have kept it to outside. So let's start with it. So all of you can see here, this bromine I am starting from here. Bromine number 1, bromine number 2 and bromine number 3, and let's see what are the conditions and what will be the oxidation state of various bromine in this compound. Okay? So in these type of cases we have to see the attachments and how much electrons are being pulled. So it will be easy for you to understand that electrons are being pulled. One bond is pulling 1 electron, so we are going to consider that concept only here. So look at this. This bromine is connected with 1, 2, 3, 4, 5, 6 with 6 bonds this side with the oxygen. Every oxygen must be pulling 2 electrons, isn't it? Now, just because 1, 2, 3, 4, 5, 6 electrons are there, because this side it is connected with the another bromine. So, oxidation state of this bromine is only plus 6, because from the 3 side it is being pulled. Okay. Next is, look at this. This will also be at the same oxidation state because the conditions are same. This is also connected with minus 2, minus 2, minus 2. Each bond, each covalent bond is pulling 1 electron if it is there towards the electronegative atom, more electronegative atom. So this is what. Now look at this bromine. This bromine is having 1, 2 pulled there, 1, 2 pulled there. So 1, 2 are being pulled from this side, and what is the charge here? Plus 4, because this bromine and this bromine, these two are not pulling the electrons of the bromine, middle bromine to any of the side. So this is at the 4 oxidation state. So let us count the oxidation state of the bromines. 6 plus 6, 12, 13, 14, 15 and 16. So 6 plus 6 plus 4, we are getting plus 16 oxidation state. And because these are of 3 bromine, This is 16 by 3 because again we are taking the average of the bromine oxidation state here. So what we are getting? 16 by 3. But the condition is these are not having 16 by 3 oxidation state, every bromine. So what is happening here? These two bromines are having oxidation state +6 and middle bromine is having oxidation state +4. So this way we can explain the oxidation state of element of various atom. The atom to atom it will differ actually. You just make sure that each bond towards the electronegative atom is pulling one electron. So by counting the bond we can assess how many electrons that more electronegative atom must be pulling towards itself. Okay. So let's begin with the next example, that is tetrathionate ion. So the name of this ion is tetrathionate ion. Tetrathionate, thio means sulfur. So do remember, wherever you see thio, it means sulfur. This tetrathionate ion, this can form H2S4O6, which is an acid called tetrathionic acid. Tetrathionic acid. And if we want to calculate the oxidation state of sulfur in tetrathionate ion, how can we calculate? Sulfur is what? 4. How many sulfur are there? 4. Oxidation state we don't know because it is oxo anion. The oxidation state of oxygen is -2 multiplied with 6 because there are 6 oxygen. Overall charge on this ion is -2. So this is equal to -2. So we can calculate it. 4x minus 12 equals -2. So it becomes 4x equals plus 10. So x equals 10 by 4 or 5 by 2. So this is the oxidation state. This is the oxidation state of sulfur in this S4O6, that is tetrathionate ion. Now again we have to go to the structure so that we can find out what is problem in this and what kind of connections are there, so that we are getting it this way. So this is the structure of tetrathionate ion. Here you can see 3 of the oxygen are this side and 3 oxygen are this side, and these two sulfur are connected with each other. Right? So these two first I am taking, these are at the zero oxidation state because they are connected with the same atom, no pulling, no pushing. They are at the no tension because they are connected with their family members. Same way, you can see here that this oxygen is connected with the one bond, and you can see this side that there is 2 minus charge of this ion. So I will provide -1 to this oxygen because it is tetrathionate ion. So ion means those charges we have to mention here. So these two charges I am giving to this oxygen because they are connected with one bond only. Now let us assign the oxidation state. So here in this case, this oxygen is connected with the 2. So this is pulling 2 electron. This oxygen is connected with 1. So it is only pulling 1 electron of this sulfur. This is already there on it. So this here there are 2 bonds. So it is also pulling 2 electrons. To 2 plus 1 plus 2. So this pull 2 from this side, 1 from this side and 2 from this side. The total charge they are getting +5. This sulfur is getting +5 oxidation state. Same way, this oxygen is pulling -2, this oxygen -1, and this oxygen is also pulling -2. So 2, 1 and 2. This is also getting +5 oxidation state. So this way we will see that these two sulfur are at +5 oxidation state and these two sulfur are at 0 oxidation state, and that is why we are getting total oxidation state 10, 5 plus 5, and we are dividing them with 4 because there were 4 sulfur. So I hope it is clear now. Let's move to the next structure, and the next structure is H2SO5. You can see here the sulfur is connected with 4 oxygen this way. So I am going to do the things in the same way as we were doing before. That is, this is pulling 2 electron, this is pulling 2 electron, and this oxygen is pulling only 1 electron. So -2, -1, -2. These are pulled from this side, and this is also pulling 1 electron. Just because it is connected with the one bond, it must be pulling 1. So this is 1, 2, 3, 4, 5 and 6 electrons are being pulled from the sulfur. So what is the oxidation state of sulfur here? +6. one more thing you can observe here, that here we are having two oxygen connected this way, and I have already told you in the last video that this connection is called peroxide, and you can see here these two oxygen are at oxidation state -1. If you want to calculate this oxidation state of sulfur in this compound, you have to mention there that these two oxygen are at the oxidation state -1. So I am using this formula to calculate the oxidation state of sulfur considering the bonding present in the compound. Let's see to it. How many hydrogens are there? 2. What is the oxidation state of hydrogen? 1. I am adding it with the sulfur. How many sulfurs are there? 1. So this is X. How many oxygens are there? 5. Now out of these 5, 1, 2, 3. 3 oxygen are at -2 oxidation state, which is a common oxidation state. So 3 oxygen are at -2 oxidation state. On the other side, 2 oxygen are at -1 oxidation state. So I am adding 2 oxygen at -1 oxidation state. Overall charge on this molecule will be 0. So let's find it out. 2 plus X minus 6 minus 2 equals 0. So it becomes X equals plus 6. So if you are considering the condition of every element, that will give you the exact oxidation state also using this formula. Otherwise you have to see the connections and then you can decide how many bonds are there, and accordingly you can assign the amount of charge on the center atom. Is it clear? So this way you can calculate it. And the next example is CrO5. If I calculate it in a simple way, I will get it done like X plus -2 multiplied by 5. So this is equals to 0. So X should be equal to plus 10 if this is a normal compound having the connections in a normal way, that is -2 oxidation state of oxygen. Now but the conditions are somewhat different. We are getting it at plus 10 oxidation state, but plus 10 oxidation state is actually not possible for any element. So let's see what is happening here. The structure of this chromium oxide is, so you can see here this connected with the peroxide linkage, this and this connected with the peroxide linkage, and just because they are connected with the peroxide linkage, 4 atoms of oxygen in this compound are at -1 oxidation state, jabki this oxygen is at -2 oxidation state. So if I want to use that simple formula, simple way to calculate it, I will do what? I can calculate it using this formula, that is Cr. I am taking X. Cr I am taking as 4 of the oxygen at the -1 oxidation state, so multiplied with the 4, and 1 oxygen at the -2 oxidation state, so this is -2. Overall charge 0, so I will get it as -4 minus 2 equals 0, that is X is as at plus 6 oxidation state. Either this way we can calculate it by understanding the connections between the oxygen and oxygen here, or the another way is that you can assign the charge using the covalent bond, that is this chromium is connected with this oxygen with 2 bonds, so this is -2, it is pulling towards itself, -1, -1, -1, -1. Each oxygen is connected with 1, 1, 1 and 1 only. So this is pulling -1, this is pulling, and this is pulling. So 1, 2, 3, 4. 4 these oxygens are pulling and 2 this oxygen is pulling. So total overall how much is being pulled? Plus 6. So there is plus 6 oxidation state on the chromium in this chromium oxide. So let's take one more example and the last one also. So here I am having example of CH3COOH. If I take this example, I can calculate the carbon oxidation state like 2x plus 3 plus 1, 4, that is 4 oxidation state plus 1. How many oxygens are there? -2 and multiplied with 2. Total charge on the molecule 0. So what is the oxidation state? 2x plus 4 minus 4, that is 0. It becomes 2x equals 0. So let's see why the answer is 0 in this case. So I am drawing the structure of this CH3COH here. CH3COO and H. So this is the structure of acetic acid. To understand the charge on each carbon here, we have to see the structure of this acetic acid, and the structure of this acetic acid is CH3COOH. And in this structure, what is happening is one hydrogen is giving one hydrogen is giving one electron, and one hydrogen from this side is giving its one electron. So total charge which is appeared on this is there is -3. So this is -3 charge appeared on it. This is a group. Just because it is a group here, this is pulling its one electron because this is having oxygen in it. So if I consider it as a group, this is pulling its one electron. So if one electron is being pulled here, so what is ultimate charge left out on this carbon is -2. Because -3 and +1 will be -2. So ultimately there is -2 charge on this carbon. What about this? On this carbon, what is the charge? So let us find it out. I am drawing the structure again so that you can understand it in a better way. So this is 1, 2, O, O, H, H, H and H. Now let us understand it again. If I consider it in a new way. So what is happening here? Again I am doing the same. 1, 1 and 1. That is, they are giving their electron -3 charge. This is not pulling or pushing any electron because both the things are carbon. Okay, so total -3 charge is appearing on this carbon. Now look at this. This is pulling its one electron and one electron, that is -2 charge on it. This is pulling its one electron, -1 charge on it. That is, it must be producing +3 charge on it. And just because these two are friends, these two are family members, this carbon will help this another carbon using one bond. Because there is only one bond, this can help only by giving its one electron. So what will happen? Ultimately, this carbon will shift its one electron to this carbon. So what will happen? -2 oxidation state of this and +2 oxidation of this carbon will appear here, and overall charge will be 0. So either you can consider it as -3 +3, that case also it is 0, or you can consider it as -2 and +2, but actually it is -2 because this structure is justifying this charge. I hope now you can determine the oxidation state of various atoms in the molecule. So I hope now this concept is very clear to you, and you can calculate, I think, all the NCERT questions which are given in your course. If you like this video, please hit the like button, share it and subscribe it also. Thank you very much.